A recent poll of 1,500 randomly selected American adults found that 945 of those sampled actively avoid soda in their diets. Use this data to construct a 95% confidence interval for the proportion of all American adults who actively avoid soda in their diets. They want us to build a confidence interval for a proportion, so that's what we're going to do. First, let's define some important variables in this problem. We're going to call lowercase p the proportion of all American adults who actively avoid soda. Since p is a value describing a population, we often call it a parameter. Keep in mind that we don't actually know the value of p. That would require getting in contact with every adult in America and find out if they actively avoid soda. And the whole goal of this problem is to get a good estimate for p based on our sample data. So how do we do that? We can get a good estimate for the parameter p by looking at p hat, the sample proportion of adults who actively avoid soda. Since p hat comes from a sample, it is often called a statistic. Whatever value we get for the statistic p hat should be a reasonably good estimate for the parameter p, because large random samples are fairly representative of their population. To calculate p hat, we look at the sample data for how many people avoid soda and divide that by how many people total were in the sample. So we look up at the problem for that information, and it tells us that 1,500 adults were sampled, and 945 of them avoid soda. So we can turn that into a proportion by dividing the 945 adults who avoid soda by the 1,500 that were sampled, and that gives us 0.63. So it's safe to say that p is approximately 63%, or in other words, about 63% of all American adults actively avoid soda. Now, the true percentage in the population is probably not 63%. Although 63% is a good estimate, the real percentage of all American adults who avoid soda is probably a little lower or a little higher than 63%. The big question is how much higher or how much lower is it? By building a confidence interval for this proportion, it will give us a range of plausible values for this unknown parameter. So, let's see what it takes to build one of these confidence intervals. Most all confidence intervals look like this. You start at a statistic, and then you go plus or minus a critical value multiplied by the standard deviation of the statistic. Before we dive into each of these components and what they are and what they mean and how to calculate them, it's important to check some conditions for using the formulas involved. Now here it depends what class you're taking, at what level, what teacher you have. For example, if you're an AP statistics student, you have to check these conditions, but not all teachers will have you check conditions to use these formulas. However, it's important to do so because otherwise you can do a lot of fancy calculations and end up with a final answer that could be totally inaccurate if some of these conditions are failed. And many teachers have you check them anyway. So we're going to see how to do each of these conditions off to the side here. Here's the conditions for building a confidence interval. The first condition is that the data came from a good random sample. A random sample produces results that are fairly representative of all American adults and lets us call 63% an unbiased estimate. The poll described in the problem passes this condition since it says it was 1,500 randomly selected American adults. So we move on to the next condition. The next condition says that the sample size needs to be large enough so that the sampling distribution of p hat is approximately normal. This will happen when we see at least 10 successes and failures in our sample. In this poll, successes and failures are just how many adults avoid soda and how many who don't avoid soda. And when we look at the problem, it told us there were 945 adults who avoid soda, that's bigger than 10, and the rest of them, 1,500, subtract the 945, that leaves us 555 adults who don't avoid soda. And 945 is bigger than 10, 555 is bigger than 10, so our sampling distribution of p hat is going to be very close to normal. This is going to be useful later because it allows us to use a normal curve for a lot of our calculations. The last condition we have says that those in the sample should be independent of each other. And we're sampling 1,500 American adults, which is less than 10% of the overall population. Large random samples are good, but sampling less than 10% of the population actually helps us here because it means that we don't drastically change the population as we sample these 1,500 adults. So we can view people in the sample as being fairly independent of each other. And we've passed all three conditions, so let's look at the formula and build the confidence interval. Here's the formula for creating a confidence interval for p. Off to the side, we're going to break down the formula into each of its three components: the statistic, the critical value, and the standard deviation of the statistic. So we'll start off with the statistic. We already calculated p hat, and we found that it was 0.63. This said that 63% was our best guess for p. The rest of the interval just has us go a little above and a little below 0.63. So we want to look at how far we go above and below. We'll start with the standard deviation of p hat formula in red. So this formula is for the standard deviation of p hat, and it's the square root of p hat multiplied by 1 minus p hat divided by our sample size n. And it tells us how much p hat will typically vary in samples like this one. So we plug in 0.63, which we just calculated for p hat, and we put in 1500 for n in the denominator, since 1500 was our sample size. And when we calculate this, we get 0.012. And we can say that p hat is going to vary by about 1% from sample to sample when we look at 1500 adults. Now remember that p hat is normally distributed. So if we want to be 95% confident in our estimation, we need to go about 2 standard deviations above and below our p hat when we make our confidence interval. 2 standard deviations above and below the mean contains about 95% of the data. And a critical value z star, that's the exact number of standard deviations above and below the mean you have to go in a normal curve to get exactly 95% of the data. So to find our critical value z star, we know it's going to be close to 2, but we sketch a standard normal curve with a mean of 0 and a standard deviation of 1, and we mark off 95% in the middle. And we think about what percent is left over, what percent is unaccounted for. And if we've talked about 95% in the middle here, there must be 5% left over. And based on symmetry, there's 2.5% left in each tail. So our critical value z star is going to be the point where 97.5% is below that point and 2.5% is above it. Now there's a lot of ways to get this critical value z star. You could use a standard normal table, and you look for what z-score gives you 97.5% of data below it, or you could also look what z-score gives you 2.5% of data above it. You could also use a calculator. Most calculators have built in an inverse normal function, but whichever tool you use, you will find that the z-score we need is 1.96, and that's close to 2 like we knew it was going to be. So that's our critical value z star. We're going to go 1.96 standard deviations above our estimate. So now we can plug each of those values into our confidence interval formula. We can stick in 0.63 for p hat, 1.96 for our critical value, and 0.012 for our standard deviation of p hat. We multiply the critical value by the standard deviation of the statistic to get our margin of error. So 1.96 times 0.012, that gives us 0.024. And that's just going to tell us how far above and below our estimate of 63% we should go. So we finish off our confidence interval by adding and subtracting 0.024 from 0.63. When you subtract it, you get 0.606, and when you add it, you get 0.654. And congratulations, we've finished creating our confidence interval. And our interpretation of this interval is very important. What do these numbers say? Well, what they say is that we can be 95% confident that our interval captures the true value of p. So in other words, we're 95% confident that the true proportion of adults who actively avoid soda in their diets is between 60.6% and 65.4%. So we have pretty good evidence here that a majority of American adults, all American adults, actually actively avoid soda in their diets based on our sample of 1,500 American adults.